So a tagged union is when you take a union and you put an enum on top of it. Then you wrap them both into a struct in a way that you can refer to this combination as a whole. In our case, it's some kind of a power-up, and I added 3 different types of power-ups, HP, magic, and some kind of a generic effect maybe. And then when you create them, when you create an instances of this power-up struct, so what you do is you assign the tag, and then you assign an inner value of an enum, of a union to its particular value. And then you can pass this struct to some kind of a unified interface to do, for example, printing. It can be anything else. And then these like generic interfaces, what they need to do is they need to switch on a type, and then based on this type they need to access internal value of a union. So if type is health, we know that we need to access that power up, that health, to get this value. We know that it's not magic, it's not effect. These will contain garbage for our purposes. And this is the most common way to implement tagged union in C. You can actually do something a bit more crazy. So for example, if we take a look at a manual for X11 X-event, X-event is a union straight away that contains type as its first member. And then it unionizes, nice. And then it has a bunch of structs and some padding laid on top of each other, in a way that for each of these structs, the first member of every single one of them is also type, in a way that memory layout matches. And then you don't need to wrap them all in this struct. You can just pass this union as is, and then based on the type, you can access internal members. You can do either of them. I personally prefer this one, and I think this is the most popular of the two. And since we're talking about C programming language here, everything is manual, right? You need to manually assign the tag here, and you need to manually sync them. For example, there is nothing to prevent you from changing. For example, you can do P1, the type, you can do magic, right? Like here. And now your power up contains garbage. So let me compile this and print it. Now you can see that it prints magic 0 because I changed the tag. So let's delete that and let's take a look at the correct output. Yeah, the correct output should be HP 100. And of course you won't be doing this on purpose. It will just happen accidentally because your code base is huge and you like accidentally access something you shouldn't do, right? But as I said, the overall concept of tagged unions is so incredibly useful that newer, like modern programming languages, they just added it on a language level itself and added a bunch of quality of life options. Let's take a look at Rust, at our favorite programming language. So this is the same exact code, but implemented in Rust. Let's compile it on, it takes a bit longer. And if we run it, so this is the Rust executable, you can actually confirm it by checking the output size. It should be huge and bloated. But yeah, if you run it, it outputs the same information. So let's look at the code. So in Rust, a union itself is just a part of enum. So you just specify enum with a tag, and in parentheses you provide its type. And when you create a power-up variant, you just specify the tag, and again in parentheses you provide it a value of a particular type. And then when you call power-up print, look how much nicer it is. First, you don't access any like internal field when you match. So match is kind of like switch in C. And then you just say, okay, match on this tag. And if it's health, then Rust will downcast to the correct internal type. And this variable of name health will just be of 64-bit integer. And magic here will be a float if our power up is magic. And effect will be a static string if this tag is active currently. So you can kind of see a, let me actually open them side by side. Here you can see the contrast here. A lot less internal state is accessible to us, and you can't just screw this up by, for example, providing an incorrect internal state here, right? So in C, I can easily mistype and put magic here while setting this sort of tag, and yeah, it's gonna be disaster. And in Rust, if you can see, for example, here, I can try to put a float here. Rust will just straight up refuse to compile the code for me. And also on top of that, if, for example, I don't provide a printer for a particular variant, Rust again will complain saying that one of the tags is not covered. So this is kind of just a famous safety of Rust. So let's go back to our C and let's think if there is some sort of, like maybe macro magic that will bring our C tagged unions closer to the quality of life that Rust gives us. And the first, and I guess the lowest hanging fruit, is of course handling the completeness of switch case. So in C at the moment, if I remove effect and let me compile C, first of all, it lets me compile no problem. And then when I try to execute it, you can see that effect printer is now completely gone. So this is covered by compiler warning toggles. Let me just add it as a pragma. So pragma GCC, this is the compiler I use, and you just type diagnostic error. So you set set it as an error, and it's -w switch. Yeah, this is the one. And now if I try to compile it, you can see that it doesn't let me. It says that enumeration value effect is not handled. So this is one. Let me get my switch back and paste the pragma. You can, by the way, provide this dash switch as a GCC argument, but I'll just get it into a code so you can just compile with GCC. And the second one is, this is kind of an annoying part about C, is that you have to put a break in here. And if I don't break, you have code just falling through here. And if I compile it and execute without a break, you can see that we get some kind of a weird result, or magic is getting printed twice. So to avoid that, we just add another pragma, which is it's W implicit fall through. And now let me actually compile it. It compiles, and if I remove the break I haven't saved the file. Yeah, now as you can see, it errors out with, oh, the statement may fall through here. And if you actually want to fall through a case statement, you can add an attribute in double square brackets. It's like fall through. Oh, it's yeah, you need to put a semicolon at the end, of course. So now if I do, it lets me fall through because I put this attribute explicitly. These like double square brackets attributes are standard since C23, and you can use something more old with like double underscore attribute, but I want to showcase this one because foreshadowing, we will be using some other C23 feature later on. But yeah, anyway, let's put our break back here. Yeah, so let me actually compile it again and run it just to make sure it still works. Nice. And so next we can automate this, I don't know how to call it, a constructor, in a way that we don't need to access internal union value when we create our variant, so that we don't accidentally screw it up. And so the way you do it is you just define a macro. So let's call it power up make, and it's gonna accept a tag and a value, and it's gonna return you a power up, and it should be parenthesized. And what you do is you put a tag to tag. Oh, sorry, it's not a tag, it's a type. You put it as a tag, and then you put an internal power up to, well, here's the problem. So if we don't want to pass a bunch of different stuff here, we need some kind of a convention that will let us keep our macro simple. And so what I propose to do is to sync the name of the tag with the internal names of variants. So for example, if a tag is named capital H health, you put it here as well. And same with magic and same with effect. So what this will let us do is you can just say power up that tag, and the macro will interpret this tag as sort of a token, right? Equals value. and you need to do a dot here, of course. Value also needs to be parenthesized. Same with the tag, yeah. And when you do this, you can now, instead of creating power-ups like that, let me copy paste it, let me comment this out for reference. So you can just make them as power-up make, and tag will be health, and a value will be 100 here, this float here, and a string here. Let's change these to round parentheses, and I think that should be it. Let me try to compile it. Oh, no. All right, I also need to change my printer here. So yeah, we will need to change these to be capital case for now. Now let me compile it again. All right, yeah, yeah. So this, I need to wrap the entire macro in parentheses, not just like this part. And now what we have here, so another thing, why did I put a dot here? Yeah, now we're finally good. So yeah, all back, all is working. So let me delete this, and now you can just call power up make, provided a tag and a value, and this like internal state is managed by us with this macro. So step number 2 is to handle our printer situation. First, we don't want to explicitly switch on a type, we want to just, match on this. And it would be cool if instead of switch here, we would just do match and, P, and that's it. So how do you do this? Well, you define another macro that you call match, and it will accept our tag union, right? And here you will just switch on the tag union dot type, and yeah, this probably needs to be parenthesized. So, and now, so let me try to compile it. Oh yeah, of course, because it is a C and we need to see implicit declaration. We need to actually move our printer after we declare our macros. And now let's compile. We do value magic not handled in switch. It doesn't like that we don't have an opening bracket here, and now we are good to go, still works. So this part is handled. Next, we need this kind of automatic downcasting without accessing internal state. We need another macro that we will call, I don't know, unwrap in the name of Rust. So what will unwrap take? It will take the union itself. So let me actually call it TU, because I just can't be bothered typing it all up. So TU, and we can also unwrap on the tagged union. Then we need a particular tag, and I guess variable name that we want to put the value into. And unwrap will replace the case branch. So we need to do literally, actually case we will type manually. So we will, I guess, put tag colon. So this will unwrap, like, for example, health colon. And then, so here we need to put like our type here. And here's where we're gonna use another C23 feature, which is type inference. So we'll just type auto var name equals to tagged union dot power up that tag, right? And I guess our tagged union needs to be parenthesized. This should do the trick. And now just do unwrap. Let's check one of them. So P, health, and I know HP, something like that. And since we have column here, we don't need it here. All we need to do is use HP, and let's check it out. Seems like it's working. Let's replace everything else. So again, unwrap P, magic, and MP, and here we just use MP, and the same we unwrapping AP on effect, and let's just call it as a full name, and Yeah, let's see if it still works. Yeah, I don't need colons here anymore because my macro sort of handles that and it still works. Nice. So you can see now that I just do something very similar to Rust, just with less of a syntax sugar. I just call unwrap on the P, on the tag, and the value that I need to downcast to. And now it looks very similar to what we have in that other programming language. And yeah, to comment on using auto as a type inference, yes, it is a standard since C23. If you don't like this for whatever reason, you know, since we're doing macro magic, we might as well use some fancier features of C itself. But if you don't like this, you can provide a type here. So you can provide like type and use type here, right? And then you would put like HP should be an integer. So this is your alternative, but I think it's kind of dumb. So just at this point, use this. It's whatever. All C compilers support it. Probably all compilers you care about. So like, why not? It's all just a thought experiment anyway, right? So next thing we want to handle is accessing internal fields. As you remember from the very start, you could still take this and it's a type and change it to magic, right? So you can still do this and you shouldn't be able to since we're going like all the way. So how do you achieve that in C? Well, C has this compiler extension that works in GCC and I'm like 67% sure it works in Clang as well. You just type pragma poison type. And now if I do this, sorry, I forgot to put GCC here, so it's a compiler pragma. Now if I try to compile it, it will tell me attempt to use poison type. So this is like a non-standard way to make a struct member, I guess, private. And you also want to ban access to the union itself. And so let's, I guess, generalize this further. Let's call this union with an underscore. And I guess let's call this a type also with an underscore. And now let's put our underscores here and let's change it to union here and same with union there. Yeah, we just want to poison both type and union. And now if we remove this, let's first see if it works. So switch, oh yeah, we need to fix switching on this. And yeah, now it all works. And if you try to change either type equals magic, right? So as we've demonstrated, this doesn't work anymore. And you also can't change the, union that magic equals, like 67.69. So you can't do this anymore. Attempt to use poisoned. And the way this compiler pragma works is that after you declare it, you can't access those members. But before you declare it, you can, right? So actually, to make it clearer, let's move our printer below the pragma and let's put it here. So our macros actually still can access it because those identifiers were poisoned after we defined our macros. So in this way, you can kind of, encapsulate these private fields and then you can poison them. So you see, we almost do some kind of, I don't want to say object-oriented programming, but you see where I'm going to, right? And now we're pretty much at a feature parity. One additional thing that is worth doing is that our constructor is not generic. It only works with power-ups, but what we can do is we can call it like tu make, for tagged union, and give it a type, like capital T type, and just, and just put it here. And now, instead of doing power-up make, we do tu make, and then here, we provide a power-up as a first argument. And now we're like creating a tagged union of power-up health 100. And if we compile it now, oh, sorry, you see, my compiler already helps me. And it works. And now we can create tagged union of other types, right? It can be like armor of light, medium, heavy. It can be, I don't like JSON serializer, you know, like array, number, or string, anything. Yeah, so that's it. And we also have a pretty nice type safety, almost like in Rust. So if, for example, in an effect variant, I try to provide like a number accidentally and try to compile here, you can see that it yells because I'm trying to initialize character star from int. The error is not as nice as in Rust, you know, but what can you do about it? It's still better than C++ templates, okay? Anyway, honestly, the whole point of making this video was just me getting too excited because I've learned that GCC poison exists, and I just wanted a convoluted use case to demonstrate it. I don't know. Anyway, if you like what you see, feel free to subscribe, and I'll see you in the next video. Bye-bye.